Morning. Yep. Okay, so let's keep trucking here. And I went a little ahead because I want to talk about a couple of things with event-driven stuff. Um, for starters, the plan is I'll be back in person on Monday. I probably could have swung it today, but I figured with the weekend and this was my only class today, maybe I should just rest a little longer, but I'm on the mend. So let's get through that and we'll go from there. All right. So, for homework today, you were supposed to go through the creating collectibles and then detecting collisions. And I've actually already written that part, but I want to talk through some of the things as we're going through there. Um, so bear with me as we dive into this. The current state of my game, I think, is probably roughly where everybody else is. Maybe I didn't make it look as pretty, but you can drive your thing around. So I want to talk about a couple of the things. Um, so let's open up our player here. So as a starting point, last time we created this player controller script, and we also added this player input. All right. So a game object is at the minimum, a game object is if we look here at my walls, here's a generic empty game object that I just used basically as a folder over here to hold the cubes that are on my walls. So if you notice that if when I click the empty game object, notice that all that a game object has is a transform. That's position, rotation, and scale. That is the bare minimum, nothing else. You can't even see it type thing. When we go to player here, we see that a player has a bunch of other stuff. I know we mentioned this last time. It has a transform, it has renderers, it has colliders. It's a rigid body, which allows us to have physics act on it with gravity turned on. Um, then we added this player input system, which I'm actually not a huge fan of, but it actually does give us an opportunity to talk about event-driven programming, as that is actually related to um, uh, asynchronous, multi-threading, things we've talked about before. All right, so if we go to our notes here. All right, we talked about game objects. I just mentioned that. Rigid bodies says let physics work on it. All scripts by default in Unity they inherit from something called mono behavior. So mono behavior is effectively the Unity magic that says we're going to include this guy in the game loop. So you have an opportunity to have something happen with that object every frame. It probably means something a little bit more than that, but I think for now that's a good enough explanation. Okay, so with that in mind, I want to add a slide here called event-driven programming. So let's think about an alternative prior to event-driven programming. What did we do? So let's assume you have a program where you just say, okay, press any key to continue. All right. Well, your program's going to be sitting there just basically busy waiting. Like, do they press a key? Did they press a key? Did they press a key? Did they press a key? Effectively, it's going to give us a blocking type situation. All right. So prior to event driven, if we were interested in a particular event occurring, we would have to check on it, call that often. All right. So, if you want to think about this in terms of like real life, You know, let's say you're cooking something on the stove or whatever, and it's one of those things that it doesn't have like a precise time associated with it. You kind of check in on it every, 3 or 4 minutes, see if it's starting to get brown or something like that. Fill in your example, whatever makes sense for your mind. Okay. So one thing you can do is you can literally interrupt yourself, whatever you were doing. So if we're going to, in this example, we're going to say you're the running program. You could interrupt yourself every couple of minutes, go and check on it, come back. So during that period of time, you weren't accomplishing anything else. All right. Now, another thing you could do is, so let's say something like, if we were interested in an event, we could just decide to check on it every few minutes or something like that. Alternatively, we could create a thread and have that thread check in on the event every so often so that we could continue doing whatever other task we were already doing. Okay, so up to this point, that would maybe be our approach as from our programming experience. So prior to us introducing threads, we would have said that we would just uh, uh, check in every so often, interrupt whatever we're in the middle of doing, pause our movie, whatever, if you want to think about that in real life. Okay. Or we can invent a little helper in our kitchen, bring him into existence, spawn a thread so that we can return back to our movie. And that guy would check on our, he would check on our stovetop, whatever the timer was every 2 minutes, 1 minute, 30 seconds, doesn't matter. Okay. But he would be doing it independently of us so that we'd be able to accomplish whatever other tasks we were doing. All right. So the issue with this, so this requires us to come up with the time interval that we wait between checks. And maybe we'll say, perhaps there is a better way. All right, so that's where event-driven programming comes in. So in event-driven programming, we can register our interest in knowing when a particular event occurs. And I'm just going to say the system, whatever that means in our case, if it's an event-driven system like Unity has, or the operating system in a computer, but the system notifies us when the event occurs so we can respond to it. Okay. Think of this like push notifications on your phone. You're waiting for something to happen, and rather than you opening the app every couple of minutes, eventually you get a push notification when something is done cooking or whatever. You send an email and something was supposed to happen, you get a push notification, or somebody texts you when it's time to respond to the next step. All right, so this is the idea of event-driven programming. All right, so this isn't something necessarily new, for us in terms of ideas, but it is new for us in terms of programming. So how does this connect to what's going on here in Unity? All right, so I mentioned that a player has, among other components, this player input component. All right, now what that ultimately does, if I go to the code here, we open up our player controller. That gives us, so here's the event. I'm just going to add a comment here. Whenever movement occurs, this function is automatically called so we can respond. Event-driven programming. Okay. So we've said we're interested in something, and because we said we were interested in it, we've effectively, by adding that component, we said, let me know whenever something has moved. Okay. And so this function will automatically get called, kind of like receiving a text message or receiving a push notification, but it is happening in a multi-threaded way, which means that when we're operating in here, when we're writing the code for what we want to have happen in here, it doesn't block the rest of the program. So I really think about Unity as a highly multi-threaded type application. There's a lot of stuff all happening simultaneously. And what we've done here is we're saying, hey, I'm interested in whenever the component that owns this script moves, let me know because I might want to do something about it. Okay. So on move, and you can kind of see this if I just start typing it. Here's on move here. So it's something that's built into the function. If I click it, let's see what comes in there for me. It doesn't show me the rest of it because I think I already have it there. Okay, but if you knew that on move was something that was going to pop up, you can just start typing it. Let's see if I can get here on mouse up. So if I say on mouse up, this guy would automatically get called if we registered for the mouse up event, if we were controlling stuff with our mouse. Let's look at on keyboard input. No, not giving us the rest of it. Or actually, maybe it was. No. So maybe less than reliable. Have to look at the documentation, but there is a world where sometimes it'll fill in some of the things we're interested in for us. I'm not sure you can fully rely on it, but we certainly can look at the Unity documentation and see what inputs on move takes. Okay, so it gives us something called an input value. Now, one thing we can do here is we can go and we can look at Unity input value, call it class, something like that. All right, so this takes us to the Unity manual. So here's the class input value. So similar to documentation we've looked at before. Now we can kind of experiment with this on our own. So we can come into on move here and we see that the parameter that was automatically passed into on move was a variable named movement value of type input value. So we could just type in movement value and then put a dot after that and get an idea of what stuff this dude has associated with it. All right. So one of the things he has is a function called get, and you can tell it the kind of thing you want to get from this, which is going to be from a collection of of components rather. So show us what the get thing was. It doesn't really tell us the list of possible components it can have. So we're just using it for a specific point here. But so in any case, one of the things that this input value has contained within it is a vector 2. Okay. And you could think of a vector 2 as a 2-element. Let's actually get this in the notes if we didn't already get it in the notes. Did we talk about vector stuff? Yeah, we didn't. So let's just get it in the notes because that's one of those things that sounds more complicated than it is. Let's say vector 2 and vector 3. Okay. A vector 2, a 2-element array typically used for holding X and Y values. So we might have, X is 4, Y is 8, something like that. That would be a vector 2. All right. So you can almost think of the word vector as in some ways being a synonym for array in our programming speak. Okay. Similarly, a vector 3 is a 3-element array typically used for holding X, Y, and Z values. So 4, 8, 13, something like that. All right, those are vector 2s and vector 3s. Nothing super fancy there. That's just what they are. All right. They just sound scarier when you first think about them. All right. So when we move our player, one of the things we're interested in is what is its X and Y position. So notice that we use the movement value. This is the value that was automatically passed in to onMove. And onMove automatically got called once we registered the player input component with this player game object. All right. So this guy knows about that player movement. So we get that movement value. We ask it to go ahead and get one of its components. What component? The vector 2 component. All right. This angle syntax here, let me just give you a little definition to that. These things transcend Unity. These are not Unity specific things necessarily. A lot of the stuff might be very common in Unity. But I'm going to call this guy generics syntax. All right. So whenever you see that guy, open, close angle brackets, in the syntax in the documentation, it is a placeholder for a class name that then allows the function to behave more specifically rather than generically. All right. And let me actually show this to you with an example from Java rather than Unity, just so we can connect the dots here. It's not overly super important, but I at least want to connect the dots here. All right, so we're going to create something in Java here called an array list. You could also do linked lists. There's all sorts of different generic things in Java. So we're going to create an array list called AR, and this is going to be a new array list. All right. Think of an array list as an object-oriented version of an array. It's a collection of stuff. All right. And we're going to say AR at bucket 0 is equal. I'm going to put the string hello world in there. Okay. Now what I'm going to do is I'm going to say string s is equal to AR at bucket 0. Now here's the reality. AR at bucket 0 boils down to a generic object, even though we know that it is actually a string. All right. So that means that if we want to be precise here, we would have had to cast it to a string. We would say, okay, this guy, I put it in as a string. So I know I put a string in there. But since this array list was built generically for holding anything that is an object, and this kind of comes down to that idea of inheritance, all right, where, everything inherits from objects. So every single thing that exists in the Java language that isn't a primitive type at some level is an object. Okay, and its most, basic level, that guy's an object. All right. So we would, when it came out of here, it would come out as a generic object. We would then say, by the way, you're actually a string. And then we would store it inside of a string variable. You probably, in this particular case, could actually get away without converting it to a string. I think an object would automatically convert to a string in Java just because Java is a string-based language. All right. I'm going to put this not using generics. And then I'll indent this stuff. And then I'm going to steal that. And then we're going to say using generics. All right. So what I'm actually going to say here now is we're going to have an array list of strings. So notice I put those angle brackets with the word string after it. And this is going to be a new array list of strings. So now what I've done is I've given definition to the generic array list. And I've actually said, by the way, you are being created specifically for holding string data types. So now when I put a string into this dude, it goes in there just like it went in there before, because this array list was built for holding anything that's an object. And yes, this is a string, but all strings are also objects. So when I put this in here, I was actually storing it as an object. Now I'm saying this collection is built for holding specifically string types. So I'm going to go ahead and try to put a string type in there. It's going to work just fine. You will not be able to put other types in here. For instance, I wouldn't be able to say new random like that and store a random object in there, because a random object is not a string, where I could have done that up here, because a random object is in fact an object. Okay. Now, when I read it out of that array list, it will come out as a string, because that's what this guy was built for holding. Okay. So that's the concept of generics. And I think that's something that exists. It's very popular for probably the last 10 years-ish or something like that. And it's common across most programming languages, and they almost always will use this angle syntax for it. All right. So how does that relate to what we're doing here? So movement value has a function called get. Now, a movement value holds a collection of potential components associated with this input value, whatever that possible list of components is. Let's just say there's 10 possible components in there. I'm sure we can look it up and find out the possible things that an input value related to movement might hold. But for right now, we can just say it holds a collection of components, just as if we click on our player game object here, notice there's several components hanging off this guy. We have a transform, we have a mesh filter, we have a mesh renderer, we have a sphere collider, we have a rigid body, we have a player input, we have a player controller, we have a material. So there's a bunch of components that are part of this game object. So we could ask the game object to get us a component of a specific type. And we actually do that in the code here. So I'll re-emphasize that then. All right, but that's kind of the idea of what we're dealing with here. So when we ask our movement value to get us a value, we're specifically telling it the value we want it to get us. We want the vector2 that is associated. So the vector2 component that is associated with this input value, whatever that means. In this case, it means the X and Y. Okay. So we're going to ask specifically for that component, and get is going to go and get that for us. All right. And we're going to store that inside of a variable built for holding a vector2. So it's going to come out of movement value as a vector2, because that's what we requested. And we're going to store it inside of a variable capable of holding a vector2. It's a variable just like any other variable. And now that we've described what a vector2 is, hopefully you see that it's not an overly intimidating thing. Okay. And then what we're going to do is we want to store a couple of pieces of information. So I'm going to scroll up here to the top of our class. So this is just like Java. I remember last time I mentioned that here's our inheritance model in C#. So instead of in Java, we would have said extends. In C#, the inheritance syntax is just a colon. So our class player controller inherits from mono behavior, which, by the way, inherits from object. Okay, so actually it's a lowercase o, I believe, in C#. So a lot of times in C#, the differences between that and Java are just capitalizations and stuff like that. All right, so that means that this particular class that we're writing, this script, we want to participate with Unity's game loop stuff, the thing that calls start automatically one time when it first starts, the thing that calls fixed update or update. Fixed update gets called every 60 times per second. So to simulate 60 frames a second, that kind of stuff. All right. So now at the top of our class, just like we looked at in Java and just like we looked at in C++, we have a collection of fields. Okay. Now notice 3 of them are private. This other one is public. We'll talk about the public one here. And well, I'll just mention it now. Whenever you want to connect something in our code to something in Unity, we make that public. So let me just show it to you real quick, and I'm going to talk about the design pattern around that. So hopefully what you're seeing here is that for homework assignments, I'm having you kind of practice using Unity, and then I'm using that tutorial to fill in some gaps. These are generic programming concepts that we're talking about here, not necessarily Unity stuff. So when I go back to Unity here and I click on player and I go down to that script, notice here that I now have this text field called speed that's allowing me to enter information here. That came from this guy right here. By making that public, Unity picked up on that and included it in the Unity interface. So that gives us an opportunity to talk about design patterns. I may have mentioned this before, but we'll talk about it again, even if I haven't, because we definitely haven't talked about MVC. So design pattern says a proposed good solution to a common problem. All right. So in computer science, design patterns are actually, well, let's not just say computer science, let's specifically call it academia. We have this idea of publish or perish in academia, where we're supposed to write research papers, yada, 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 things like that. So kind of a layup version of that, a way that you can write research papers easily is by coming up with an idea for your own design pattern. Whether it's a good idea or not, you can say it's good, and then in your paper you can say, well, there might be some better approaches or something like that. All right. So the punchline here is that the good and common are kind of in the eye of the beholder. All right. So let me give you an example here. What is the best way to make a PB&J, peanut butter and jelly? All right. So, I'm sure if I polled the class on how each person makes a peanut butter and jelly, we might have 2 or 3 different little approaches to, the best way. Like maybe you find that you want to keep your peanut butter at room temperature, because if you spread cold peanut butter onto bread, you might rip the bread, that kind of stuff. What I do is I usually use a spoon and I scoop a couple of scoops of peanut butter on there, and then I squeeze a bunch of jelly and I actually spread it by mashing the bread together, whatever. All right, we have different approaches to what might be a good solution. All right. Now, typically, a design pattern has a crazy name. All this branding. All right. So maybe I would have, the crazy Lippmann approach to peanut butter and jelly making or something like that. All right. But certainly if we have our, the people in the classroom and we each come up with our own little written thing of what makes a good peanut butter and jelly, we might have 2 or 3 different approaches that we can put forward. We'll name each one of them. And we would put forward those guys as design patterns whose ultimate goal is to solve the problem, the common problem of making a peanut butter and jelly. Okay. Now, typically, though, when we talk about design patterns in the world of software engineering, what we're really talking about is approaches to software development. So one of these design patterns is something called MVC. Okay, MVC stands for Model View Controller. All right, so Model View Controller. Now, first of all, let me put this back on the previous slide on design patterns. A design pattern is not an implementation. It is an approach to an implementation. All right. So if you gave the design pattern for making a peanut butter and jelly, you're not handing them a peanut butter and jelly. You're handing them a list of instructions that is a proposed good way of making a peanut butter and jelly. Okay. Now, having said that, this idea of the MVC design pattern, which we're going to talk about, every application that might be interested in this might implement it a little bit differently, but it ultimately has the same goal. So MVC basically says it is a good idea to keep your code separate from your user interface, separate from your data. Okay, so model, this is the data. View, this is the user interface. So for us, this is the Unity visual stuff. In our case here, the view is what we see over in Unity. This is our view world. And controller, this is the actual code that contains the logic. So in our world here, this is the Visual Studio C# code. Let's just call it C# code, in case you're not running it in Visual Studio. All right. And notice we've already kind of given a nod towards this when you look at Unity and you see what we've called some of our assets. If you go into scripts, notice we named this player controller, camera controller. So controllers are code for controlling a game object. Just a naming convention, doesn't have to be called that, but that's kind of where this idea came from. A controller contains the logic for doing something. All right. So model view controller basically says that it's a good idea to keep your syntax, your code, separated from your user interface and separated from your data. There should then be a convenient way for each of those things to gain access to each other as needed. All right. So from an organizational perspective, we want to have all of our C# code in one place and all of our user interface scene design stuff in another place and all of our database stuff in another place. But sometimes you need to bring those guys together to accomplish something. And we're seeing one of the ways that Unity accomplishes that right here when we look at our code and we see that, oh, by making this guy public, we're going to say this is how Unity MVC allows us to expose a variable. Let me put this on a line before it actually. To call it from the controller to the user interface. All right. Let's put in parentheses, view. All right. So just by putting public in front of this, it automatically will pick up that variable and expose it over here. So that we have access to it over on the Unity side. All right. So that's the idea of model view controller. We haven't worked with data yet, so just kind of leave that on the side for right now. The model part is, you know, when we create a database or we're using a third-party API and pulling data in from someplace else, whatever it is. Data is the model part. Otherwise, view is what we see. Controller is the code we write. Okay, so let's get back into the code here. So on move, as I mentioned, automatically gets called because we've added that component to the player. That we've added whatever it was called, the user interface, player input component to this guy. And this guy is also the one who owns this player controller. So since the owner of this script is our player, and our player also has the player input component, this on move function will automatically get called. Okay. So what's the first thing we do? We extract the vector2 from our movement value, and then we go ahead and set these two variables, movement x and movement y, equal to those two values. All right. So with that in mind, remember, variables resolve to their most local definition. So we have movement x here and movement y here. We're not defining them on that line. And we look here inside of on move and we don't see it. All right. So what we need to do is we need to move outside of that guy and go to the next level where it could potentially be. And we scroll up. So it's not going to be in one of these other functions, but we're going to leave on move and go up to the class level. And we see that we have two private floating point values, x, move x and move y. That's where those guys were born. That's where we created those variables, and their scope, where they're accessible, is anywhere inside of this player controller class, including on move. Okay. So we'll set that field movement x. I typically like to say this dot, if you want to connect this to the way I usually write this dot movement x, this dot movement y, setting it to those values. So now I have access to those somewhere else. Okay, somewhere else in my my program. So now let's see where they're used. So fixed update is called once per fixed frame rate. So this is simulating 60 FPS, 60 frames per second is what we're trying to accomplish there. All right, so with that in mind, second here. Okay. Inside a fixed update, what are we going to do? Well, we're going to create a new instance, a new variable. So we're creating a variable named movement, and this guy is of type vector3. Okay. So we already talked about what a vector3 is. This is an array of 3 elements, an x, y, and a z. Okay. So that vector3 is going to be made up of whatever movement x is for the x thing. And actually, we're using the movement Y in place of the Z in 3D space. So if you we go back here and you want to think about our game here, let me hide this and run the game because I can see this being slightly confusing. We're sitting here inside of three-dimensional space. X is the axis that goes left to right. Y is the axis that goes up and down. Z is the axis that goes forward and back. That's why we use the Y element from our vector 2 to control where our player is moving along the Z axis going into the screen. Okay, so that's the rationale why we put the Y actually where the Z goes, if that makes some sense. All right. And that's something you're going to kind of get used to, is thinking in three-dimensional space from those kind of things, because we're going from a two-dimensional domain of X and Y and moving to a three-dimensional domain of X, Y, and Z. So wherever we're supposed to move, we're going to create a vector 3 with X on the X, Y on the Z, and we're just going to leave the up and down at 0. All right. So with our marble is not moving up or down at all. Okay. So now, what are we going to do with that vector 3? So after this line, all we have is an array with 3 elements in it. We haven't actually used that array for anything. So where does this RB come from? So let's look up here. So we created another field of type rigid body named RB. So this guy is accessible anywhere inside of the player controller class. All right. That means it's accessible inside of fixed update. That means it's also accessible inside of start. All right. Remember, start, this function gets called one time at the very beginning when this script first spins up. And I'll go ahead and add to that the idea of, if you can write a script once and you can actually attach this script to multiple things, well, it would get called once per thing. All right, because we have multiple instances of this script. So we could actually create a second player and have both players moving around at the same time because they both have their own version of this script. All right, but this is just a global variable inside of player controller. Here in start, when the script first starts up and just one time, we're going to go ahead and say the rigid body owned by this instance of the script is going to be equal to, I'm going to again say this get component, and I'm actually going to spell this out a little bit more. Some of these things are kind of bypassable. They've made it as a convenience for working with Unity, but really what we're saying here is I want this instance of player controllers RB variable, this rigid body, to be equal to this guy's game object. That is the game object this script is attached to. And I want to take that game object and I want to get a component from it. What component? Well, here's my generics here. I want to get the rigid body component from that. Okay. What game object is this script associated with? It's associated with our player game object. So let's go back in here. Here's our player. Here's our player controller script. So this .game object would be this player game object. And we see here that this guy has a component called type rigid body. So we're asking this game object to give us the rigid body component associated with it. Okay. Now, we were allowed to do that because get component associated with this guy allows us to specifically talk to the game object, because that's the only thing that would make sense to get the component from if you're inside of this script without using another variable type. So this is allowed, but I would maybe discourage it just because I like to be more explicit. Similarly, you didn't even need to use this, okay? Since we are inside of a non-static method, that is, start doesn't have the keyword static in front of it. It's owned by instances of the player controller class. So that means inside of this function, this dot is assumed to be there wherever you haven't put it, because we are in an instance-based context or a non-static context. Okay. But again, I like to spell it out. So I would say this dot game object dot get component. All right. And maybe the piece here that I would say is important is just because something works doesn't mean you should use it. At the very least, I want you to understand why it works. What's actually happening on this line is we are talking to the game object that this script is attached to and asking him to get one of his components. Which component? The rigid body component. That's what's actually happening in detail, even though you have a little bit of a shorter syntax. I like to call it syntactic sugar for kind of pulling that off, if you will. All right. So inside of start, we go ahead and get access to the rigid body, so that inside of fixed update, remember start only happens once, fixed update happens 60 times every second. So inside of fixed update, we're going to create a vector 3 with whatever the current value of movement X and movement Y is. And then we're going to take our rigid body. Remember, the rigid body component is the way it makes this game object react to physics, react to kind of physical forces. So we're going to take that rigid body, and again, I would probably say this.rb, whatever, and we're going to add a force to it. Okay, and the force we're going to add is a vector 3. So that means we're going to shove that game object with a force on the X, the Y, and the Z component. Now, we're always passing it a 0 for the Y, so it's not going to go up in the air at all, but we're going to kind of be shoving it, forward and over, depending on kind of the angle it was moving. So we're adding this force to it. All right, that's our movement. Now, speed, this is how hard we're pushing. So we decided to make this controllable. We went ahead and said public float speed, started it off at 0. So that allows us to control that over on the unity side. All right, and we're going to take that vector 3 and we're going to multiply it by speed. This is effectively linear algebra. So this is this vector is being multiplied by a scalar. So we're shoving it harder in each direction. All right, the current value for speed I have in here is 10. If we switch it back to 0, you'll see the guy moves pretty slow. He is moving just super, super slow. I can even experiment with it while it's running, but remember, any changes you make while it's running will not be permanent. So I'll change that to a 10. Now you see it moving faster. Okay. Now I'll change that to 100, and you're going to see him moving too fast. All right. So you get the point, but if I stop this now, you see it goes back to 0. So you can play around with it during runtime, but remember that it will switch back. So 10 kind of felt like a decent enough number there for moving around. All right, so that's what's happening 60 times every single second, is we're going to figure out the direction we want to shove the player and then actually shove the rigid body component, the physical presence of that player, along that vector 3. Okay. Nope, sorry. So that's what's going on here inside of the player controller. So hopefully that added a bunch of color commentary to what you were working on. All right, so at this point, you have finished the creating collectibles and detecting collisions with collectibles. So we'll talk about that with triggers and stuff on Monday. So over the weekend, let's go ahead and finish this guy. So the last two pieces of the tutorial, notice this last thing is just kind of the full tutorial walkthrough. But so displaying the score in text and then ultimately building the game if you wanted to run it directly on your computer rather than playing it inside of Unity. Okay, so I'll put the homework assignment up. So for Monday, do these last two parts, then you'll have this complete. I'll finish talking about that hopefully on Monday, and then we'll start writing our code for doing our own thing using some of these primitives. Questions, comments, concerns, bribes? Okay, I will see everybody on Monday.